So first up, before we are moving to the video, so sorry for the delay, and the good news is that the video contents up until chapter 2 have passed the pre-production stage already. That means I have prepared all the contents already to be ready to put in the slide. Okay? And also, to announce further, the videos from this lesson to the fourth lesson. So this lesson is lesson 2, right? So these 3 lessons will be released in the next Saturday, which for each week I'm going to release 1 clip per week. So if you do not want to miss any video clips, please subscribe so that you see the updated contents once it comes. Okay, so let's move to the content. So for this chapter, we are still at chapter 1, okay? And this lesson we are going to move to the specifics, because last time we talked about the axioms of the general properties of probability measure, and this time we're going to talk about the finite sample space and simple sample space. So let's start. Finite sample space means that the sample space S contains finitely many elements. Okay, so we can list S1 to Sn, where n is finite. Then, after we got each element of the sample space, we assign the probability that the outcome of this experiment is, the outcome of each experiment, that is Si, is Pi. So, like last time, we are going to narrow down the axioms of the probability measure into 2 basic axioms, where we are going to use these properties quite often, because the finite sample space is the case that we deal quite often. Okay, so the first property is that the probability measure is non-negative. So this is like the last time, right? And second property is that the sum of the probability from PA1 to Pn is equal to 1. Why this 2? Because remember that the probability of the sample space is equal to 1, right? And for the sample space, we can list S1 to Sn. So sum of Pi from I equal to 1 to n is equal to 1. So let's move to the first example. Consider an experiment where 5 fibers of length 1, 2, 3, 4, and 5 inches are tested to see which fiber will break first. Suppose that the probability that any given fiber will break first is proportional to the length of the fiber. So, what is the probability that the length of fiber that breaks first is not more than 3 inches? So let's think about it. First, since sample space is finite, we can list the outcome from S1 to S5, where Si is the event that fiber of length I break first. Then, we assign probability Pi equal to alpha I, where alpha is a fixed number. Why do we need this? Because we are going to apply the second axiom in order to find alpha. So, from the second property, P1 plus P2 plus P3 plus P5 is equal to 15 alpha, which is equal to 1. Therefore, alpha is equal to 1 over 15. So, we are almost ready to answer the question. So, the question is that, what is the probability that the fiber that breaks first is not more than 3 inches? That means, we are going to find the probability measure of X, where X is the set of S1, S2, and S3. So, P of X is P1 plus P2 plus P3, because each of the element is the element of the sample space, and surely these are disjoint. Okay? So 1 over 15 plus 2 over 15 plus 3 over 15 is 2.5. 2 over 5. Okay, so we have dealt with finite simple space already. Once we know the axiom of probability measure from last lesson, this will become very easy because this is just the special case. Okay, and another special case that we deal with it quite often is simple sample space. Simple sample space is that if we list the element of the sample space as S1 to Sn. So this is called the simple sample space if the probability to each outcome Si is equal to 1 over n, which is equal to all of the events. That means if event S, that is event that we are interested in, has exactly m outcomes, so the probability of X is equal to m over n. It is a very simple formula. But we have to make sure first that the sample space that we deal with is simple. Okay? And if not, and if we want to apply this formula, we have to transform it first. Okay? Let's look at the second example. Consider an experiment where we roll two balanced dice. What is the probability that the sum of two numbers that appear on the dice is equal to 5? So, the sum of the dice may be equal to 1, 2, 3, up to 12. But this is not simple sample space. We cannot say that, oh, the probability that sum of two indices appear on the dice is equal to 5 is 1 over 12. We cannot say like that. Because this is not simple sample space. The chance that the sum is equal to 1 is smaller than the chance that the sum is equal to, let's say 4, for example. So this is not simple sample space. But in order to use the previous formula, we have to list out like this. So this is the list of the 36 outcomes, and we could define S like the pair of ij, where ij belong to this set from 1 equal to 6. So S is a simple sample space because we have list all 36 outcomes and the dice is balanced. So define X as the tuple ij, where ij belongs to S and I plus j is equal to 5. Finding the probability that the sum of two numbers is equal to 5 is equivalent to finding probability of X. That means we are in the right direction. So if we count probability that I plus j is equal to 5, so I plus j is equal to 5, we have 1, 4, right? 1, 4, 4, 1. And let's say 2, 3, 3, 2. And done. So we have 4 outcomes. 4 outcomes that we are interested in out of 36. So that means if we form the solution like this, we can apply the formula like this. M equal to 4, N equal to 36. So probability of X is equal to 4 over 36 is equal to 1 over 9. So this is the special case. We have dealt with two special cases of the probability measure, namely the simple sample space and finite sample space. And in the next lessons, we are going to deal with the combinations, multiplication,